Hello Math 130 students. We are going to pick up on page 22, section 5.7 variation. So here with direct and inverse variation, we're always going to be looking for k, and then we're going to be using k. So here, the following statements are equivalent. We say y varies directly as x, meaning that y is equal to k times x. If it varies inversely, then it's a fraction, where k is going to be your numerator. And here, if it varies jointly, then everything gets multiplied together and k is still there. So let's take a closer look at number 1. It says the amount of money Sally earns P varies directly with the number n of necklaces she sells. When Sally sells 15 necklaces, she earns $150. Write the equation that relates P and N. How much money would she earn if she sold 4 necklaces? So this is a lot of information. You want to think as part 1, or the first sentence there, is giving you a clue of what you're going to be using. So varies directly. So varies directly is going to be that y is equal to kx. So that is this over here. So varies directly. So varies directly. Now that we have that general formula, we're going to have to kind of split this up a little bit. So we're going to have our part A, and we're going to have our part B, where this relates to part A and this relates to part B. So for part A, it says write the equation that relates P and N. So I want the general equation. So usually it's that y is equal to k times my x. But here they give us different variables. Instead, the variables that they gave us is P, so we're going to have P is equal to your K is the only thing that's always going to be fixed, and it says with the letter N, so N is the number of necklaces she sells. And they also give us some information. The information that they give us is that she sells 15 necklaces and earns $150. So here the number of necklaces, N, is 15. And she earns $150, which is your P amount. So now you have these values. Now you have that your N is equal to 15 and your P is equal to 150. So now you can plug these values in. So for P, I have 150, and it's equal to my K value that you're trying to figure out. And your N value is 15. So to get the K by itself, you're going to divide both sides by 15. So here, 150 divided by 15 is going to give you 10. So 10 is equal to K. So now your general equation, you have that P is equal to your 10 times your N. So that is your general equation. Now for part B, it's going to ask you, well, how much money would she earn if she sold 4 necklaces? So you know that P is equal to 10 times my N value. And here in particular, it says that your N is equal to 4. So P is equal to 10, and that N value that you're plugging in is 4, so P is equal to 40. So here, your amount is going to be $40. So for every 4 necklaces that she sells, she earns $40. Now, looking at number 2, I'm going to have the same type of problem going on. So I'm going to go ahead and split it to my part A and my part B. So it says the maximum load of a beam will support varies directly with the square of the diagonal of the beam's cross-section. A beam with diagonal 6 inches will support a maximum load of 108 pounds. Write the equation of the load L to the diagonal D of the cross-section. How large of a load in pounds will a beam with a 10-inch diagonal support? So here, the first sentence is part A, and that second sentence is part B. So I want to find my general equation, and the key wording here is varies directly. So in general, y is equal to k times x for my varies directly. Now, it specifically says that we want to write the equation with load of L. So here's my load L. So here, the maximum load, so that's going to be L, is equal to, and you know that k is always going to be fixed, and it says with the square of the diagonal. So to square something, that means your exponent is going to be a 2. So to square the diagonal, that would be a d. So it would be d squared, the square of the diagonal, okay? So the piece of information that they give you here is that diagonal is 6 and the maximum load is 108. So I have my load of 108. So L is equal to 108. And here your diagonal is equal to 6. So diagonal is equal to 6. So when I plug this in, I'm going to have 108 is equal to the k value that you're trying to find being multiplied by your 6 that's being squared. So you have 108 is equal to your k value being multiplied by 36. So I'm going to have to divide by 36 on both sides so that you have 108 being divided by 36 and you get 3. So here 3 is equal to my k. So your general equation, you're going to have L is equal to your 3, and it's times your diagonal squared. So that is going to be your general equation. Now for part B, this is where I'm going to answer this question here. So I'm going to use my general equation that I have, that L is equal to 3 times my diagonal squared, and it gives me pieces of information. It says how large of a load, so the load is unknown, in pounds will a beam of a diagonal 10 inches diagonal support. So here the diagonal is equal to 10. So L is equal to 3 times my 10 being squared. So L is equal to 3 times 100. So L is equal to 300. So it's 300 pounds. So a beam with a 10-inch diagonal support will be able to support 300 pounds. Now for number 3, it says if V varies inversely with W and V equal to 18 when W is equal to 1/3, find the equation that relates V and W. So for this one, my main concern is varies inversely. So we are going to take a second and look up the varies inversely. So if I'm looking at varies inversely, then I have this fraction where y is equal to k over x. So I'm going to go ahead and write that down. So I went ahead and wrote down that y is equal to k divided by x. So here that was our general, but remember our variables are different. So our variable says if v varies inversely, so instead of y, I have v, and up on top I still have the k, and it varies inversely with w. So w is what we're going to have, okay? And now they give us some information. It says that v is equal to my 18, and it also says w is equal to 1/3. So to find this k value, I am going to have 18 is equal to that k, and I have a 1/3 on the bottom. So the only way to get that k by itself is either to multiply by 1/3. Okay, so this is being divided by 1/3, so to get the k by itself, I will be multiplying by a 1/3. And so when I do that, my 1/3 times 18 is going to give me a positive 6. So 6 is going to equal to my k value. So now my general equation I have that v is equal to my 6 divided by my w. Okay. So here they're really just asking us for a part A. They did not ask us to find a part B. So I found the general equation. Now for number 4. I'm going to go ahead and skip ahead and say that it varies inversely. And so I know that I have my y is equal to my k over my x. Okay, so now I'm going to read it. It says the fuel consumption in miles per gallon for a car varies inversely with its weight. Suppose a car that weighs 3,000 pounds gets 28.7 miles per gallon on the highway. Write the equation that relates y, the fuel consumption in miles per gallon, to the car's weight w pounds. So, okay, so it says that it has my y. So I have my y is equal to my k, and it says the fuel consumption in miles per gallon to the car's weight, w in pounds. So those are in particular the variables that they want me to use. They want me to use y, and they want me to use the w, okay, since it varies inversely with its weight, w for weight. So what do we know? Well, we know, suppose a car that weighs 3,000 pounds. So here is a weight. So my w is equal to 3,000. And here I'm going to get my 28.7 miles per gallon. So 28.7 miles is going to equal to my y. So that's miles per gallon. So that's your y, your miles per gallon. So I'm going to plug in my information. So I have a 28.7 is equal to that k value, and that w is 3,000. So here, to get k by itself, I'm going to multiply both sides by a 3,000. So I'm going to have 3,000 be multiplied by 28.7, and I get let's change the color here, 86100. So 86,100 is equal to my k value. So now I can write my general equation. So I have that y is equal to, and that k value that I just found was that 86,100 over my w. Okay. Again, they just want the general equation, so that is my general equation. All I needed to do was use that k value, and that gives me my general equation. Okay, and that is the end of this section and of chapter 5. We just wrapped it up very nicely. So if you guys have any questions, please feel free to email me or the Math Success Center or our tutor. Remember, we have a tutor that's embedded, so he's here just for you guys, okay? All right, thank you. Bye.